In this tutorial, we will work with patches. I have here in front of me a sheet with boundary conditions already applied and a patch bounded to the center of the sheet. The sheet is made of aluminum A20-2043 and has a thickness of 10 millimeters. The patch is a fiber reinforced polymer with the material properties that you can see here. The patch is a single patch, which means it's just one patch bounded to one side of the sheet. And the attachment is a bonded one with an adhesive which has 1 millimeter thickness. Okay, so this is our initial setup. What is missing here, and I will add, is the crack. I will add a crack here to the center of the sheet. So I'll just come here and select to add an embedded crack, place it at the center, and define its initial half length as 5 millimeters. So with this, we have here our structure complete with the crack here at the center. What I want to do is to just run a crack propagation analysis here, so we can see what happened to the stress intensity factors with this configuration of a single patch. And we will then run the same problem again, but making this attachment, this patch, a double patch, right? And then we'll compare the stress intensity factors to see the differences. So I will just run the crack propagation analysis. I want this crack to grow up to 50 millimeters in 10 stages. And I want the attachment to behave in an elastic fashion. We'll check this behavior later. So I just click run. And we have the analysis complete. And now I will just select the patch and make it a double patch just by clicking this here. Right, you just have to change this, and now I have a double patch, and I can run the same analysis again. Well, I have now two analysis, two results, one considering the patch is a single patch and the other one considering that the patch is a double patch. I'll just compare this. I'll come here and I want to compare it in overlay mode. So we can see that the two cases I have here is for a patch with the flag double equals no and double equal yes. So then I select, I want to compare a crack tip result, which is a stress intensity factor. I will just choose tip 1 and for all stages of crack growth. And just by doing this, I'll just hide here the fracture toughness. We can see that the stress intensity factors are very different if I consider the patch single or a double patch. And I hope I have shown how easy it is to make these comparisons in XGD. Okay. Next thing I want to do is to take this, I will delete the first analysis because I just want the patch to be a double patch. But what I want to do now is to show you how to perform a parametric study. So the variable I want to study is the thickness of the patch and its influence in the stress intensity factor. So I will just come here. I have the first analysis where the patch had 0.3 millimeters, and I will run now a few analyses just with different patch thicknesses so that we can compare later what happened to the stress intensity factors. So I'll first change this from 0.3 to 0.9 and run the same analysis again. Then I'll change it to 1.4. and run the analysis again. The analysis of bounded patches is a very complex problem numerically, right? But you see that it's running in less than 7 seconds. I will then change again to now 2 millimeters and run. And then the last one, 2.8 millimeters. And run it again. So now I can come here and compare results. You see that we have all our cases here where the patch thickness is changing. So select elastane, again, crack tip, stress intensity factor. I'll choose just tip number 1, doesn't matter because it's symmetrical, and all the stages of crack growth. And we can see here, I'll just hide the fracture toughness. We can see here the complete influence of the patch thickness. At the top here, we have the patch with the 0.3 millimeters. Obviously, the patch is less stiff, and then the stress intensity factors are higher. And down here, the opposite, the patch at 2.8 millimeters, which makes the stress intensity factors much lower. So this is how easy it is to consider a patch either single or a double patch, and how to run to perform a parametric analysis, choosing any variable, running it again, and then comparing the results in the end. With that, I conclude this tutorial video. Thanks for watching.